this chapter 6, okay, you notice the first lesson is 0.6. That's not a mistake. It is from chapter 0. So in the beginning, so you have chapter 1 in the book. Before that, there is a chapter 0. Each one of the lessons in that chapter 0 are like an introduction to one of the different chapters in the book. So it just so happens that lesson 6 is an introduction to chapter 6, lesson 8 is an introduction to chapter 8, whatever, okay? So this first one is from chapter 0, like at the very beginning of the book. Okay, so in this chapter, we're going to be talking about systems of equations, all right? And the first thing we're going to talk about is matrix operations. So what is a matrix? A matrix is a rectangular array, right? An array is just like an ordering of things. It's a series of things. It's a rectangular array of variables and constants. This is why math teachers love matrices, is because everything is, arranged neatly in rectangles and rows and columns in a matrix. So we have rows and columns, and these rows and columns are enclosed in brackets. Each value of a matrix is called an element or an entry. In other books, it might be called an entry or an element. It's the same. Okay. So the thing is, they have to be arranged in rows and columns. Okay? Now, how do we talk about dimensions of a matrix? The dimensions of a matrix, or basically the size of a matrix, but we never use the word size, we always use the word dimensions, is written as m by n, and it's basically read m by n, and what it is, it's the number of rows and columns. So for example, take a look at this matrix here, all right? Let's talk about rows and columns. So each one of these is a row, and you can see this has 3 rows, and it's got, if each one of these is columns, it's got 4 columns, so we say 3 by 4. It's very, very important that rows go first, then columns, right? Otherwise, like if you say 4 by 3, it's a completely different sized matrix, right? So rows, then columns, 3 by 4. Okay. Now, so in here, we have 3 rows, 4 columns, and we have, all the different elements in here. Each element, yes, it has a value, but it also has a label or a name, okay? And the name of each element is basically the place that it holds. It's basically like where it sits in the matrix, okay? So imagine if instead of calling you guys by your names, I said, okay, student like 2-1, or student, 3-2, or student 4-3, right? That's sort of what we're talking about. So the name of a matrix is given by a capital letter A. Okay? It's given by a capital letter. It could be A, B, C, D. So this is matrix A. Each element, like this one, is given a name. So if the matrix is capital A, this is little a, and what position does that hold? This is row 2, column 1. So this is A, 2, 1.
Oh.
Okay? Little a, 2, 1.
Like a 2-1.
Wait.
Yeah.
Are they the same?
Right. 2 for second row. 1, 2, second row. 1 for the first column. So now let's do this one, -8. Which row is that in?
3.
Third row. So it's A, 3, second column, 2. You don't have to put a comma. We understand that like it's not 32. Okay, so let's do this one. What are the dimensions of A? 2 by 3.
Do you is that all you do? Like you don't say like it's like
That's it.
Wait,
No,
so
no.
the first one capital A or
Lowercase. The capital A is just the name of the matrix.
Do you want the X to simply, like, does that affect it at all?
No, I mean, just times. It's like times. It's
Oh, yeah.
2 times 3, yeah.
Because, like, you put, like,
Huh?
you put, like, where the top.
Oh, yeah, it doesn't matter. Yeah, it's convention. Okay. So how about this one? Find the value of A23. A in this matrix.
Oh.
Row 2, column 3 is -8. Okay? So that's -8. Okay. Okay. Now, let's talk about some matrices with special names. A row matrix, as you can imagine, is a matrix with only one row. It could have as many, elements in there as you want, but it's just one row. So for example, this is a row matrix. What are the dimensions of this matrix, by the way? How much?
1,
One row. How many columns?
4.
4. So it's a 1 by 4. Okay? It takes a little getting used to. But once you do, oh my God, I love matrices. A column matrix has one column, right? So so this is a column matrix. How many rows in here?
2.
2. So this is a 2 by 1. Okay. A square matrix is a square. It has the same number of rows and columns. This is a 2 by 2. You can have a 3 by 3, a 4 by 4, an n by n, okay? That's, okay. A zero matrix is a matrix of any size or dimension. It's just every element in there is a 0. What's the dimension of that one, by the way?
2 by 3.
A 2 by 3. Okay, now, the best one of all, an identity matrix, is a square matrix in which every element on the main diagonal is 1. Okay, so what's the main diagonal? You go inside your matrix, the first element, row 1, column 1, that's this one, right? You draw that diagonal all the way through. That is the main diagonal. Only the one that goes that way. It doesn't have to go that way. Okay? So this main diagonal has to be all ones, only ones, and the rest, everything else has to be a 0. That's the identity matrix. What is the point of an identity matrix? We'll learn in the next lessons. Okay? All right. Matrix operations. Okay, this is important. Matrices can only be added or subtracted if they have the same dimensions. Okay? 2 by 2, 2 by 2. 5 by 4, 5 by 4. That's it. It's very like cut and dry, all or nothing. Okay, and the way in which you add them is very, very simple. You take an element in your first matrix, the corresponding element in the second matrix, you add them, and you put them as the answer in that same spot. Okay? You take the one here, add it to the one in the same spot here, put it here. Okay? It does. It's like math. It makes sense. Add these two, right? It's math. Of course it makes sense. And then the same with subtracting. So let's do this one. Then it's undefined or not possible. So, okay, so look. So here you have matrix A, B, C. Do you see how this is a different dimension?
Yeah.
Now you want to add A plus C, but that doesn't work because they're not the same dimension, right? So you just say not possible or undefined. I really don't care what you say, right? I mean, just one of those things. It's not like right or wrong if you say one over the other. It's just, you can't add them. Okay, the next one is B minus A. Okay, these two can be added because they are subtracted because they have the same dimension. Now, my advice to you when you're doing this, always rewrite your matrices in the order. Okay, I'm so excited I'm yelling. I'll tell it down a little high pitch. It's exciting. I love matrices. When you're subtracting or adding or whatever, always rewrite them in the order that you want to do the operation. So, because the only thing that can get you into trouble here is you just you lose concentration. That's it. Okay. So we're going to do B minus A. So this is B minus A. Right. B minus A. Okay. These are each 2 by 2s. Their answer is also going to be a 2 by 2. Okay? Now, okay, choose this one, 10 minus 2, right? Like the ones in the corresponding spaces. You were subtracting, so 10 minus 2, 8. Okay? So this one, subtract these two. What do I write down? Negative 7. These two, subtract. What do I write down? Okay. And then these two, subtract. What do I write down? 13. That's it. You're done. You just added matrices or subtracted matrices. Right? Huh? It's so straightforward.
No, they're definitely going to get like 10
No,
harder.
no, they're not. They're really not.
Misha, this is 6-0.
No, no, no.
Why would you manifest it? It'll get.
No, no.
At least this lesson.
No.
Is this like a calculator with lesson?
This is no calculator.
Oh.
Not the entire chapter, but there are going to be lots of parts. So there are going to be lots of parts that you're going to have to do without a calculator, but then there are also going to be a few things where I'm only going to teach you how to do it with a calculator, not by hand. So you need, so we need both. Okay. Scalar multiplication is basically when we multiply a matrix by a whole, like not a whole number, sorry, a plain number, right? A number outside of a matrix on its own is called a scalar. So in the world of matrices, there are sort of like different levels of like society almost. The matrices are like the nobles. And then you've got like the scalars who are really like, they don't have the same stature as matrices. They're just scalars, right? There is a little bit of a thing.
It's like Gossip Girl.
Huh? It's like, yeah, it's math. We're not gonna discriminate. Okay. So, right, so what you do is, when you have to multiply a matrix by a scalar, you just multiply each of these terms by that number. So -3 times like each and every single one of these, right? So it's going to be -3, next to it -15, 0, 6, +18, -12. That's it. Yeah. Uh-huh. Okay. Huh? Yeah, the scalars, they're really like, yeah. Well, I mean, I wouldn't go that far. Okay. So matrix operations. Okay. So matrix operations also you'll find out in the next few lessons. Well, there aren't that many lessons. Like in 6.2, you'll find out that in a lot of ways, matrices behave like the numbers that we know, but when it comes to like certain things, it's like a completely different process. Some things hold true for matrices as they do for numbers. So for example, commutative property, like you could do A plus B, B plus A, it's the same. If you have to add 3 matrices to each other, you can do the first 2, then add to the next. You could do it in any order, just like numbers. Distributive property also works when you're distributing a scalar. So, going with that, here we have matrix A and B. We have to do 3 times A minus B. A and B are matrices. So the thing is, there are 2 ways you can do this. You can distribute this, and you can do 3 times A, 3 times B, and subtract them, or you could just do like PEM does. So here's what we're going to do. We're going to do 3 times A minus B. So we're going to make like a large parenthesis. Here is A. And B. Okay, here we go. Look. So So, yeah, so matrices are put in brackets like this, and then in math, right, you usually like alternate, like parenthesis, bracket, parenthesis, bracket, parenthesis, bracket, but whatever. So this is 3 times A minus B. Now, we're going to follow order of operations. So 3 times, let's subtract these two. So what's the first one? So if I do 5 and 1, 4, and then next to it, -2. Next to it, -1 minus -2, 1, right? -3, 4, -4. Okay? And then distribute the 3. Sorry, am I going too fast? Yeah. So when you distribute the 3, that's what you get. Okay, I'll pause here for a sec. Let me stop this. This lesson is basically just an overview of everything else that we're going to do with matrices. And to that end, another thing you can do with matrices is you can use them in equations. So look, let me show you what I'm getting at. If I had, if you have this equation, okay? 3x equals minus 6 equals 10. You've been solving these equations since you were little, right? So this is, 3x equals 16, x equals 16 over 3. You can do this with your eyes closed, right? When you get at, okay, so the 3 is a number, the 6 is a number, it's a real number. When you solve for x, you also get another real number, okay? Now, we can have a similar equation, but instead, the x, instead of it being a real number, it's a matrix. And all of these other players are also matrices. All right? So, we can solve equations involving matrices using algebraic methods. In this case, the variable in the equation represents a matrix. So, the solution will also be a matrix and not a simple number, not a scalar. Okay, so how do you solve an equation? Basically, just do the algebra, solve the equation for x, and then substitute the matrices. So, take a look at this equation here. 2x minus a equals b. Okay, we're going to solve it for x. So here is my equation. Notice how everything is capital. Yeah. If it's capital, that means they all represent matrices. A, b, x are all matrices. So, let's solve this for x. So, a matrix, right. So 2x
So do you multiply 2?
is a plus b, right? Move, like add a. So here, let me do this. We're going to add a to both sides.
And so then you just multiply.
Divide.
So when you do 2, so do you add a plus b and then multiply by 2?
No, divide. So look, now it's 2 times x, right?
Yeah.
So now I'm going to divide by 2. That means I'm going to multiply by 1 over 2. So capital X is 1/2 a plus b. So capital X is, okay, once you solved it, now substitute the matrices in there. 1/2 matrix A plus b. I know, lots of brackets again. You guys can figure it out. So this is 1/2. Let's add those matrices, these two. Huh?
Divided by 2.
Because here I divided by 2. You can do that. You can do that as well. I just like this way because it's cleaner a little. I don't know. It's preference. So 2, -2. Did I do this correctly?
I got 4, 2, 0.
I got that.
Oh wait, just kidding. No, it's -4, 2. Yeah.
So it's -1. Good. So it's -1 plus -1. So it's -2. And then when you distribute the 2, the half, it's 2. I know. Well, Okay, so I did make up this problem, but in hindsight, next time I'll do one where we get fractions, because then people think there is something wrong when we get a fraction on a test.
Can we put decimals or fractions?
Fractions over decimals all the time. Any day, yeah.
Right.
Okay, so that's x. Okay? All right. So that's it. That's section 0.6. Okay. One thing super important. Okay. Well, two things super important. One, look at the homework here. It looks a little weird. It's page P27. This is not a typo. In your book, there's page 1, 2, 3, 4. Before page 1 are a series of pages that start with P. This is chapter 0, so it's like in the very beginning of the book. So the homework is from page P27. That's number 1. Number 2, a lot of people have been emailing me saying that they can't log on to the textbook, and when I also went, I also couldn't log on to the textbook. What happened is somehow there was something about like expiration dates or whatever, and then we all got kicked out of the book. In your emails, I've emailed you all a code with which you can add a new book and you can have access again. Okay? All right.